Welcome to the Bodhi Academy. My name is Amisha Classo, and in today's video we'll continue with our class 11 chapter 6 equilibrium. So today we are going to talk about the ionic equilibrium in solution. Okay, so in this following section we will specifically talk about the equilibrium that involves ions. Now it is well known that the aqueous solution of sugar does not conduct electricity. So why is it so? Like whatever solution is, say there is any solution, some of them will conduct electricity, some of them won't conduct electricity. So why is that happening? So if we look at ionic equilibrium in solutions, first thing we need to know is something. There is any if we have a solution which is conducting electricity, we say there is a flow of ions that is happening. Okay, and then we have something known as electrolytes. Now electrolytes are substances which conduct electricity in their aqueous solution. So if the solution is in aqueous medium, then they are known, and if they are conducting electricity, then we call them as electrolytes. Then further, electrolytes are further divided, and the ones which do not conduct electricity in aqueous solution, they are called as non-electrolytes. Now these electrolytes are further divided into two more categories, that is the strong electrolytes and the weak electrolytes. Now the strong electrolytes are the ones which on dissolution in water are ionized among almost completely and are called strong electrolytes. As in, say I have a salt of NaCl, okay, common salt, sodium chloride. Say if I mix it in water, what will happen? It will completely dissociate into two, its cationic form and its anionic form. So it is completely dissociating into its ions. So such electrolytes are called as strong electrolytes. Now the ones which do not completely dissolve or dissociate in water or partially dissociate, these are known as the weak electrolytes. Now what is exactly this ionic equilibrium? So the equilibrium that is formed between ions and unionized substances is called as the ionic equilibrium. So just now how we discussed, we have strong and weak electrolytes. Okay, so we have ions which are getting ionized and the ones which are not getting ionized. So the equilibrium that forms between these two kind of substances is known as the ionic equilibrium. Now further, let's talk about what are this acid, bases and salts. Okay, now all this while we discussed about acids, bases, salts, what are exactly this and on what basis do we differentiate which one is an acid, which one is a base, and so on. So now acids are substances which turn the blue litmus paper red. This we have already learned in our lower classes, and also that they liberate dihydrogen on reacting with some metals. Bases are the substances which turn red litmus paper blue. It is bitter in taste, and common examples are NaOH, Na2CO3. Okay, so these are two these are the basic definitions. One is acid, it turns blue litmus paper red, bases turn red litmus paper blue. Acids are usually sour in taste and bases are bitter in taste. A common example of acids would be acetic acid, HCl, and common example of bases would be NaOH, Na2CO3. Okay, now there was Arrhenius concept of acids and bases. Now different scientists tried to classify acids and bases based on their different researches that they did. One was Arrhenius concept of acid and bases. So now what Arrhenius said was that so acids are substances which dissociate in water to give hydrogen ion. So he said that if there is any substance, okay, if you dissolve it in water and if it diffuses to give us H plus ions which are there in water, then they are called as acids. Okay, and bases are the ones which on dissociating into the solution will give us OH minus ions. So acids will give us H plus and bases will give us OH minus ions. So this was Arrhenius theory of acids and bases. See, if you have, like, look at this example, CH3COH, acetic acid, plus if you dissolve it in water, it gives you CH3COO minus, as in this H which was over here initially, this H is getting, this H, it dissociates. Okay, it dissociates and it goes and joins with this H2 over here. So it becomes H3O plus, and this one loses a loses a hydrogen or a proton, and it gets a negative sign. Now this Arrhenius concept of acid and bases had few limitations. First was that according to Arrhenius concept, an acid gives H plus ions in water, but he said that the H plus ions, they cannot exist individually or independently. They need to be paired up with someone, because reason was because they have a very small size and they have also intense electric field. That is the reason on dissociating, H plus won't remain as H plus in the solution. It will go and bind or combine with someone. Now it does not account for the basicity of substances like ammonia, which does not possess a hydroxyl group. Now if we know, we have NH3 ammonia, right? NH3, NH4, this we have. Now if we consider these as bases, correct? But now, do these bases have OH group? No, they don't have this OH group. So how on, if we are saying that only bases are the ones which on dissociation gives us OH minus, then how come these are also bases? So these were the two major limitations of Arrhenius concept of acid and bases. Now to overcome these two limitations, another scientist came into picture, wherein they came up with the Bronsted-Lowry acid and bases concept. Now in this, they said that an acid is a substance which is capable of donating a hydrogen ion or the H plus, and bases are able to accept that hydrogen ion. So what they said, that if it is an acid, okay, it will give away one of its hydrogen ion, that is, it will give away its H plus ions. And if it is a base, then it is capable of accepting a hydrogen ion, that is the H plus ion. So it is basically, if we look in other words, acids are going to be the proton donors, as in they are giving a hydrogen, and bases are going to accept them, so they become the proton acceptors. Simple example, if we look here, we have say HCl, that is an acid, it is dissolved in water. Okay, so what will happen here? We know acid, HCl is a acid, correct? So what it is doing, it is going to give away its proton. So its proton is this H plus. It is giving away its proton to this H2O. Okay, so H2O becomes a base over here. Why? Because it is accepting the H plus and going to H3O plus. This one is giving its proton and going to Cl minus. H2O accepts the proton and goes as H3O plus. Now, another new topic is that acid, bases and its conjugate pairs. Now, what are these conjugate pairs? So, the acid base pair that differs only by one proton is called a conjugate acid base pair. Now here, if we looked at HCl example, what is happening? Only one proton is getting lost, not like 2 or 3 protons are getting lost. Only one of them is getting lost. So in a pair wherein the give and take is just of one proton that is happening, such pairs are called as conjugate acid base pair. Here what we are saying, that here water which is there, it acts as the base because it is accepting the proton. So Cl which is there, okay, Cl over here, this Cl, it is conjugate base of HCl, correct? Because it is formed by what? Giving away a proton. And the HCl, this HCl, it is the conjugate acid of Cl, because it has given away one of its hydrogen, and here this Cl is formed by losing that hydrogen. Similarly, H2O, this H2O, it becomes the conjugate base of acid H3O plus, and H3O plus becomes the conjugate acid of H2O. Next, we have another theory, that is the Lewis acids and bases. Okay, so according to Lewis, acid is a substance which accepts electron pair and base is a substance which donates an electron pair. Now after talking about all of this stuff, electron, protons, now it is not possible for us to every time to give a proton, correct? Because some of the acids also will be there which won't even have a proton to give. So in that case, Lewis came up with another theory saying that acid are the substances which can accept a electron pair and bases are the ones which will prefer to donate a electron pair. Electron deficient species like AlCl3, BH3, H plus, etc., they all act as Lewis acid. Why? Because they have a plus sign, correct? See, this can accept, even this one can accept, this one can also accept. While species like H2O and H3, etc., they can donate a pair of electron and therefore they act as Lewis bases. Now last, let's talk about the ionization of acids and bases. Based on this, finally it was concluded what is exactly acids, what are its conjugate acids, and bases and conjugate bases. Now strength of an acid or a base, it is determined with the help of extent of ionization in aqueous solution. So how much of ionization is happening, how much of dissociation of bonds is happening or ions is happening, based on that only we can define how strong an acid or a base is. Another one is a pH scale, that is hydrogen ion concentrations are measured as the number of grams of hydrogen ions present per liter of a solution. Since these concentrations are very small, the concentration is generally expressed as pH of the solution, pH being the logarithm of the reciprocal of the hydrogen ion concentration. Okay, so about this pH we will study in the next class very in brief. Okay, now just to understand the last part, let's look at this equation. We have ammonia, NH3, okay, acid, and this is our base. Okay, say why this is acid? Because it is going to accept an electron, and this base which is there, it is going to donate an electron. So what is going to happen? This is now according to whose theory? Lewis acid. What Lewis said, that acid is a substance which accepts a pair of electron, correct? So it is accepting this hydrogen. Okay, so therefore this becomes the acid according to Lewis theory. And the other one, that is the other part of it which accepts the electron, and the product that is formed, that becomes the conjugate acid. And the base is the one which gives away its 2 electrons, or it gives donates a pair of electron. In that case we lose hydrogen and we get this OH minus. If this is the base, then its opposite, that is after losing the hydrogen, whatever is formed, that becomes the conjugate base. Okay, so that was all about this ionization, equilibrium in solution, and understanding the various definitions of acid, bases and salts. So that was it for today's video. I hope you have understood. Please don't forget to like, share and subscribe to the Bodhi Academy.